For over 4 decades, Voyager 2 has been drifting quietly into the abyss, far beyond the reach of planets, past the cold edge of the solar system, into the great unknown, a ghost ship guided by Earth's last whisper in the 1970s. We imagined it would fade quietly, its signal dimming into cosmic noise, but it didn't. Just recently, it sent something back. Not just data, not just a routine transmission, but a message that made NASA scientists stop. A sudden spike, an unexpected shift, a sharp line crossed, and with it, confirmation of something humanity had long feared, but never dared to say out loud: that the edge of our solar system is not a blur. It is a wall, and beyond it something changes. If you're fascinated by mysteries like this, make sure to subscribe so you don't miss more deep space. Revelations: when Voyager 2 crossed what's known as the heliopause, the boundary where the sun's influence ends and true interstellar space begins. It was expected to be gradual, almost poetic. Scientists believed that the solar wind would fade into the interstellar medium like a slow dissolving mist. But what Voyager 2 detected was the opposite. The transition wasn't slow. It was sudden. One moment it was inside the sun's protective bubble. The next it was beyond it, in a place where radiation spiked by over 70%, plasma density jumped, and the very structure of the magnetic field changed. It was like opening a door and stepping into an entirely different room. The readings were not subtle. They were abrupt, sharp, as if a membrane had been pierced. What stunned researchers most wasn't just the presence of a boundary, but the precision of it. The sun's heliosphere, once thought to gently bleed into space, was now revealed as a distinct shield-like structure, one that had been holding back the chaos of the galaxy. And as Voyager 2 stepped through, it confirmed that our solar system isn't just floating in space. It's protected by something. Until now. For decades, the idea of the heliosphere was considered theoretical, a bubble of magnetic and plasma energy shaped by the solar wind. But Voyager 2 showed it wasn't just theoretical. It was vital. Inside this shield, conditions are relatively stable. Radiation is filtered, space weather is manageable, and cosmic rays are diminished. But the moment Voyager 2 stepped out, all of that changed. The data showed intense particle energy, chaotic magnetic flux, and dangerous levels of galactic radiation. Suddenly, the solar system appeared not as a lonely outpost, but as a fortress, and stepping beyond its walls meant entering an unregulated frontier. The smooth curves and soft boundaries that existed in textbooks were gone, replaced with hard numbers, jagged spikes, and terrifying implications. Voyager 2 was no longer just drifting. It was being bombarded. The sun's magnetic field had been aligned almost perfectly with the interstellar field, a phenomenon no one expected, one that raised questions about how the galaxy's own structure might be shaping the space around us. The heliosphere wasn't just a field. It was a threshold, and crossing it had consequences. One of the most shocking revelations from Voyager 2's data was that the heliosphere isn't fixed. It breathes, it moves, it contracts and expands based on the sun's 11-year cycle, changing its shape and thickness as solar activity rises and falls. Voyager 1 and Voyager 2 didn't cross at the same place, nor at the same distance, and the differences were not random. They were shaped by the rhythm of the sun. This means that the boundary of our solar system isn't a neat sphere. It's distorted, almost comet-shaped, with pulses that ripple outward like the breath of a giant organism. At times it stretches. At times it recoils. And if the solar wind weakens, the boundary draws closer to home, allowing more galactic radiation to seep inside. If it strengthens, the barrier pushes outward, shielding us more effectively. The implication is disturbing. Earth's protection isn't permanent. It fluctuates. It can fail. And Voyager 2's sharp transition into the galactic medium revealed just how thin that veil truly is. The cosmos beyond isn't empty. It's violent, unpredictable, and much closer than we imagined. In 2019, something strange happened. Voyager 2, reliable for over 40 years, went silent, not for long, just for a few hours. But in those hours, every instrument went offline. No commands were issued from Earth. No updates were sent. Then, just as mysteriously as it had gone dark, the spacecraft came back, rebooted, recovered. The official explanation was hardware aging, possibly a minor software glitch. But buried in the technical reports were notes on unexplained electromagnetic spikes right before the blackout. Fluctuations in the magnetic field, sharp surges in particle energy, small but not insignificant. The question that lingered wasn't just what caused the glitch, but what Voyager 2 had just passed through. Some scientists suggested it could have been a pocket of highly energized plasma, a ripple from a distant supernova, or a shock wave from some other interstellar event. But others quietly wondered whether Voyager had crossed into a layer or zone we didn't even know existed, one with properties so foreign that its presence couldn't be predicted. And if that's the case, it wasn't just a system failure, it was a reaction. When Voyager 2 stepped outside the heliosphere, it began recording fluctuations in radiation levels and plasma density that didn't align with anything previously modeled. These weren't just one-time spikes or occasional irregularities. They were dynamic, persistent, and patterned, almost like a form of weather. The idea that space beyond the sun's reach might contain something akin to weather was previously dismissed as poetic exaggeration. But Voyager 2 was registering waves of high-energy particles, sudden directional changes in the magnetic field, and surges in galactic rays that echoed with a strange rhythm. At first, scientists tried to link these disturbances to known solar events, flares or coronal mass ejections that might have echoed through the heliopause. But when those timelines didn't match, they turned outward. The patterns began aligning with distant galactic phenomena, possibly remnants of supernovae or the collective force of massive stellar winds far from our system. It was as if Voyager 2 had entered a region alive with activity, a kind of interstellar sea with invisible currents and unseen tides. And now that the probe was outside the sun's protective barrier, it was fully exposed, floating through a storm we never expected to find. One of the most unexpected results from Voyager 2's crossing was the near-perfect alignment of the sun's magnetic field with the galactic magnetic field beyond. This discovery left theorists scrambling. For years, models predicted turbulence at the heliopause, a clash of magnetic directions, a blending zone where solar and galactic forces would twist into chaos. But that's not what Voyager found. The transition was smooth, too smooth as if the fields were already synchronized. Two possibilities emerged, both equally unsettling. Either the region beyond our solar system had been shaped and bent by the sun's outflow over time, slowly sculpting itself into alignment, or the region itself was already aligned inherently. That would mean the sun and its surrounding interstellar neighborhood had evolved within a magnetic harmony, one that possibly spans a much larger section of the galaxy than previously believed. It also means cosmic rays might flow in more easily when fields are aligned, creating efficient channels into our solar system during quiet solar cycles. This wasn't just a magnetic surprise, it was a paradigm shift. The idea that the galaxy's structure might already accommodate or even anticipate the sun's magnetic reach challenges every model of interstellar interaction. Suddenly, space didn't seem so chaotic. It seemed organized. As data continued streaming from Voyager 2, a whisper began circulating among theorists and mission insiders, one they weren't ready to put on record but couldn't ignore. What if the heliosphere wasn't just a boundary? What if it behaved like a checkpoint? The sharpness of the transition, the perfect field alignment, and the consistency of radiation spikes across both Voyager 1 and Voyager 2 suggested not just a physical interface, but a responsive one. Some proposed the boundary might be adaptive, adjusting its intensity or location in response to pressure from either side. But a more controversial idea emerged, that the boundary itself might serve as a kind of galactic tripwire, a region where entering objects are exposed, measured, recorded. This was no claim of aliens, no assertion of intelligent design, but simply the observation that the space Voyager had entered felt structured, layered, reactive. And if true, that would mean every object that exits the solar system doesn't just leave the sun's domain. It announces its presence to the galaxy beyond. Voyager 2 unknowingly may have triggered more than just measurements. It may have sent a signal, and in doing so, it may have revealed more about us than we ever intended. Attached to Voyager 2 is a message, a golden disk etched with humanity's greetings, sounds, music, and diagrams. A beautiful attempt at interstellar diplomacy. But within that disk are detailed instructions: how to locate Earth, how to read the disk, how to understand who we are. For decades, this was celebrated as a symbol of hope. But in light of Voyager 2's discoveries, some now see it differently. If the boundary between our system and the galaxy isn't a gradual fade but a well-defined edge, if it reacts, If it watches, then what does it mean that we attached a map to our home on the very probe that pierced that edge? Were we extending a hand or revealing a vulnerability?